Welcome to the project demonstration of speed controlling based on the zones and obstacle detection and stopping the vehicle, automatic braking system. So your speed detection, location based speed detection will be achieved with the help of RF transmitter sections, and the same data will be received by this RF receiver module, and then after the data will be decoded, and the decoded data will be given as input to the PIC microcontroller. So so-called location names will be displayed on the LCD screen. And also while we are running the vehicle, if any obstacle detects, automatically braking will be applied to stop this vehicle movement. So in this version we are demonstrating with the help of four-wheel drive robots, so which has a 4 DC motors. There's a PM DC motors which is of 60 RPM DC motors we are using, and that 4 DC motors attached to the microcontroller through this L293D motor driver. So which will get the power supply from this 12 volt 1 amp rechargeable battery. So the 12 volts DC input to this one, and from this only we are going to get the 5 volts DC output, as this board consists of 7805 voltage regulator which will take 12 volts DC inputs and provide us a 5 volts DC output. So that is the operating voltage of our ultrasonic sensor, LCD module, PIC microcontroller and our RF receiver module. And the same 12 volts DC is the operating voltage for the 4 DC motors. So that will be getting from this L293D motor driver based on the input from our PIC microcontrollers. The input is nothing but when we on this robot, then and only the vehicle will start moving. If it is in normal zone, means there is no signal input from this RF transmitters. It's a normal zone, it will move with some certain speed, that is a high level speed. And while moving the high level speed, if any obstacle detects, automatically braking will be applied and the motors will be stopped moving. And if any school zone or hospital zone input will be given, then automatically the speed will be reduced to the 50%. And there also, if any obstacle detects, it will stop moving by applying the brake to that. So we are using RF transmitter module. So this one consists of this red color chip is the RF transmitter, and the data will be getting from the switches. So one switch only we are using for demonstration purpose. So that is the input to this encoder IC, that is HT12E encoder. After the data encoded, it will be transmitted through this transmitter module. Same data will be received by this receiver module, which is a red color chip, and thereafter the data will be given for the decoder IC, that is HT12D. After the decoding the data, that was input to the PIC16F72 microcontroller at B0 B1, and the so-called data will be displayed on the 16:2 LCD screen, which was connected at pin number B2 to B7, and continuously distance will be measured from the obstacle sensor using this SR04, and which was interfaced at the A0 and A1. And so-called speed will be controlling through this L293D motor driver, which was interfaced at the C2 pin of our 72 microcontroller. So here before demonstration we should keep the battery under fully charged. So for charging purpose we are provided with transformer. Connect the transformer 2 pin at this slots as is shown, and now on the power supply to this cable. So the lights show the status of battery is charging. It will get fully charged in duration of 6 hours minimum, 8 hours maximum. So before that, if the battery will get fully charged, then automatically these diodes will block the current flow in order to protect the battery from overcharging. So the charger consists of diodes and a filter, capacitor which has a filter, and these diodes will convert the AC to DC, and the next DC pulsating DC, and pulsating DC to pure DC with the help of this capacitor, right? So as we discussed before demonstration, keep the battery under full charge. And now first of all, on any one of the zone, there we can see the light indication on that, and the below switch below means off state, above means on state of this particular zone. And now on the power supply, this is the main on off switch. Above is the on, below is the off. So let us see. Whenever the obstacle is less than the 30 centimeters, automatically the brake will be applied. So initially welcome message displayed, it will move with high speed. So when obstacle detects, automatically the brake will be applied. As of now it's normal zone. Now let us see with this school zone. When I on this, means when it will enter into the zone, school zone, the speed reduced. We can observe the wheel speed also, and normal. Okay, and coming to the second zone, just off the power supply to this and on this. This is the hospital zone, right? So while you demonstration, if there is no input to that, if you on and off this also, then check the battery, means you need to replace this battery. or you need to keep the battery under charging. Only these two are the problems we are going to face while demonstration. So let us see the demonstration on the floor directly. Right, now let us see. Keep this on. Okay, on this. So initially it will go with the high speed only. So you can observe that. And obstacle detected, stops again. So it's moving slow speed. So when I'm off this, it's moving fast. When on, moving slow. And obstacle detects, stops automatically. See now. Slow speed and obstacle detects, stops again. Right. So in this manner we are going to do this. Right.